Welcome back, everybody. So we are on part 2 of day 4. So we're going to talk about how to actually solve quadratics by graphing. So first of all, we talked about how our x-intercepts are our real solutions. Okay, and so we can solve quadratics by graphing 2 different ways. So we can do it by hand, and we'll talk through how to sketch through a graph. We can use it by calculator, okay, or we can use Desmos, and in these times, everybody, we are using Desmos. So what I'm going to do is I'll walk through these examples and have you do it by hand, and I'll also insert a Desmos graph into here so you can double check and we can talk about what to look at on the graph. So example 4 says, graph the following quadratic equations to determine the solution. So if the solutions are rational, so this is a new word for us, if the solutions are rational, we're going to then write the equation of the polynomial in factored form, okay? And what rational solutions mean is that we can, we are able to express as an exact solution, okay? Versus if they're approximate, okay, we're going to round to the nearest hundredth. And so what I would hope you understand at this point is I can graph any parabola, but my answers aren't always going to be exact. It's not always going to be an x-intercept of 2. It could be an x-intercept of square root of 5. And in that case, it would not be exact. So that's what we're going to work through today. Okay, so our first example, x squared minus 5x plus 6 equals 0. And we're going to solve it by graphing. So we're going to graph y equals x squared minus 5x plus 6 into Desmos. Okay, so I'm going to graph the function, and the key is I want to make sure I plot the x-intercept. So in this function, I have an x-intercept of 2 and 3. I also know that my parabola opens up because my a value is 1 and it's positive, so I know my vertex is going to be below. So I actually know my y-intercept is 6 as well. 1, 2, 3, 4, 5, 6. Remember, that's our c value, so I'm going to graph my function. Okay, and again, when we're focusing on our x-intercepts, my parabola, my vertex is not that good. I also graphed it in Desmos. And notice my x-intercepts. I also put the vertex on there just for you to see. But my real solutions are x equals 2 and 3. And if you wanted to write the equation in factored form, so we're going to that would be correct. Now, please note that these two answers, 2 and 3, are rational solutions because they're exact, meaning I could have also found it by factoring. Okay, our next example is solve x squared minus 5x equals 7. So the first thing we need to do is make sure we have all our terms on one side of the equal sign, and then what I want you to do is to plug that function into Desmos. So I entered the function into Desmos, and I clicked on my x-intercepts, and I got a solution of 6.14 and negative 1.14. Those are not exact, so what this means is I do have real solutions, right? It crosses the x-intercept, so x equals negative 1.14, comma 6.14. But notice that I can't write it in factored form because I don't have exact roots. Okay, so we're just going to leave that blank. So what's important to note is that these are our approximate, also known formally as irrational solutions. So when a quadratic equation has irrational solutions, it means that we cannot use factoring as a method to solve. So if I were to summarize on A, if we were talking about what methods we can use, I don't want to highlight her. I can solve by factoring or graphing, and I would both get my exact solutions. Now over here on B, if I were to solve, my only method of solving is graphing, because there's no way we can factor, meaning there's no way we can have two numbers that multiply to -7 and sum to -5. We know that's not possible. So what I want you to do is try graphing C and D by typing it into Desmos and identifying our real solutions. Now, if our solutions are rational, meaning they're exact, I also want you to write the equation in factored form. So if you could kindly pause the video and then unpause when you're ready to check your answers, that would be great. See you soon. Okay, so you should be able to check your answers. For C, we should have gotten x equals -0.393 and 3.393. Excuse me, that was my dog. And then for D, you should have x equals -4, 0.5, and 3 as your solutions. At the bottom, I did just summarize. So for C, I have, what do we call these? We call these irrational solutions, which tells me that the only method I could solve this quadratic is graphing. And then over here I have rational solutions. These are rational. So I could solve by factoring or graphing if I wanted to. So at this point, we have two methods of solving quadratics, factoring and graphing, and they each come with different advantages and disadvantages. So let's talk about that. So factoring, what's awesome about factoring? I hope by now we would realize that factoring is efficient, meaning it usually takes a step or two, okay? But the problem with factoring is, why can't we always use factoring to solve quadratics? And that's because not all quadratics are factorable. And so, sadly, if everything was factorable, we'd only have one method. We wouldn't have four that we're going to eventually learn. So, for example, remember one of the graphing ones was like x squared minus 5x minus 7 equals 0. It doesn't factor. It has solutions, but we can only find them by using a different method. Okay? Okay, so let's talk about graphing. What's awesome about graphing is it's always going to provide us our real solutions. So again, our real solutions are our x-intercepts. Okay? But the question is, why can't we always use graphing to solve quadratics? Because above we just said we could. And the answer is because with graphing, not all of my answers are exact. And eventually, by the time we get to method 4, we'll be able to get an exact answer. Okay? So why can't we always use graphing to solve quadratics? I'm going to write because, if I can spell, doesn't always provide exact solutions. Okay, so if I think back to the example we did, I think it was C, we got like negative 0.393 and 3.93. That's a solution, but it's approximate, right? And so by the end, when we get to method 3 or 4, it's going to help us find our exact solution. So it's a great check. We're going to use Desmos a lot to check our solutions. But again, sadly, it doesn't provide us exact solutions when that's being asked for. So right now we have two methods, factoring and graphing. You're going to take a quiz on graphing, and then the next week we're going to move on to the next method, which is using inverse operations.